All right, so let's talk about JavaScript. All right, so JavaScript is it's a language that we typically associated with browsers and the web, and indeed is certainly that's where it made its name. Even though today we see that it's becoming a language that has become more and more important even on the server side. But mostly has made its mark as a language for being able to interact with the browser. The browser originally was only meant for just creating static content for sharing research results amongst physics folks that were researching their topics. But quickly we started looking at how is it that we could programmatically interact with the browser. And all the rendering that the browser does as it parses the HTML. When the browser parses the HTML, it generates an object representation of the text that it parses out, right? And it creates this tree of nodes that represent each user interface element. Every rectangle that you see on the page is represented by some object in memory in the browser. That set of nodes is referred to as the document object model, the DOM. And what JavaScript allows us to do is to interact with this DOM programmatically, right? By either iterating and creating new instances of these objects in memory, or deleting them, or manipulating some of their attributes, all programmatically as we can handle user interfaces, events as the user types or drags the mouse or whatever they do. We can associate those events with programs that manipulate the DOM and give the user some feedback. To use JavaScript, we use the script tag, and within the script tag we can embed the scripts right on the page, although it's considered to be bad practice. But it's certainly the fastest way or easiest way to start using JavaScript is inside of any HTML document. So for instance, here it's a simple alert that displays hello world. We can also generate content either as a pop-up, or we have also a console that we can write to. This is a poor man's version of a debugger, where as it's running, we can log messages to the console so that we can debug it. To see the console, you can right click on the back of any page, of any HTML page, and click on the inspect. If you go to inspect, a tool, an inspector pops up on the right hand side that has several tabs on the top. That the default tab is the Elements tab, and the Elements tab allows you to see the DOM. This is what the HTML. This is what the browser has interpreted the HTML. So it has parsed the HTML and has built this object model in its memory. And this is its interpretation. Notice that it has all these collapsible, this inverted tree, starting at the root and then getting more and more deeper. Notice that it's rendering so that it looks as it's HTML, but that's only for our convenience, right? So that we can look at the raw HTML and we can this interpretation, and we can see that they match, right? If you highlight different elements on the page, it highlights them on the left-hand side, so you can see that this particular div represents that rectangle on the left-hand side. It also displays on the right-hand side for whatever element that you click on. It displays the styling, the CSS that was applied for that particular DOM element to look that way, right? With all sorts of attributes there. The more interesting part that we're going to be spending a lot of our time is here in the console. So in the console is where we're going to be able to print messages by using console.log. We can print anything we want. We can print just strings, or we can print an entire object, and the object would be visible here, and you could inspect the object as you go. You can also look at source, any source that was downloaded from from the page. Although this is certainly it's Google, and Google is pretty good at obfuscating any of their code so that we can't reverse engineer their content. Yeah, so this is their JavaScript, and it's pretty obfuscated. It's pretty hard to read, and it's meant to do that. So this would be the JavaScript, and you could presumably put some breakpoints and run the code and step through it and see the values of your variables, and you could debug this whole thing right here, right? So you have an entire development environment here right on the browser, right? So it's pretty cool. So we'll be using this inspector quite a bit throughout the semester, right? So become familiar with this. All right, let me close that. You can also just write to the HTML template once the document is parsed, once the document is rendered on the page. JavaScript, you can use JavaScript to continue writing to the page, right? Using a global variable called the document variable, right? Document represents the actual document that was parsed. It represents that the model, the document model that was converted from the HTML to this data model. So document is that data model, right? And it allows you to traverse the HTML programmatically, navigating from one node to the next, or just appending to the current content by just using the .write. Right? And this would append content at the very bottom of the HTML page. You can also retrieve, very much like in XML. You can navigate through the XML structure by finding other elements by their unique identifier, or by a class, or by the name of the element, or so you can very much like a query. You're querying this data model, right? This data set using these criteria. In this case, by ID. jQuery builds on top of this low-level, get element by ID, by class, builds on top of that to give you a much richer API, to interact with the DOM at a higher level, as opposed to at this very low level, element by element. Okay, so jQuery, for instance, would allow you to get a hold of a set of elements, right, that all have a particular class, and then paint them all red, or change all their fonts all in one swoop, right? As opposed to retrieving and iterating over every single element here. Yes.
This document don't write, it's write to the object document object in the memory, or
yes,
write to the exact HTML on the disk.
So this is represented in memory. So document is in memory, and whatever you do to that document immediately reflects on the HTML window. Right, so if you programmatically remove a particular node or change its style, it immediately updates the file on the disk. No, there's no file. Okay. Yeah, no. This is only in memory. Yes, only in memory. So here's an example of a hello world, just retrieving that hello element by its ID of hello. So this will return from the document, return that one H1 that has that particular ID of hello, which you can then bind it to a local variable, so for further manipulation. Right? So once you have it assigned to a variable, you can then do additional manipulation. For instance, one of the things you could do is change the foreground color that is being used for rendering to either red, or you can specify RGB hexadecimal code. You can change the font size. You can change its display value so that you can hide content so that it's not rendered on the front end, or you can render it as in block, meaning take up the entire width of the page, right? Let's see. You can also work with dates. You can instantiate new date objects, and dynamically write the month and retrieve the month elements from the date. Now, just remember that the month is 0 based, so January is 0, not 1. Careful there. You can also handle arrays. You can where you can display the entire array right on the HTML document. Obviously you can iterate over an array and do math calculations and divisions and additions and whatnot. Everything you would expect from a serious language. And at the end, we can display maybe the total and then the average. Here's an example of iterating over that same array. And as we're iterating over the array, we are dynamically rendering line items, right? An unordered list, where we first render the opening tag of the unordered list element, and then as we go, we render several li elements in there, right? And then we close the UL. Okay? So this is all appending to the document elements. Here's the same thing, but using a table. So in this case, notice that in this case, we are dynamically adding elements as we go, right? We add the UL element, we add the LI element, and then close the LI element, and then at the end we close it. Or what we could do instead is generate an entire string, right? With all its complexities and whatnot, and just using append, just string appending. Once we have a complex HTML element, we then write that entire string, and then it gets added entirely to the DOM. So here's an example, right, where we start with a string, and then we just keep appending to each row appending each column, right, and then at the end we append the closing table, and we write the entire table at one swoop, right? Now, in both cases, this is very error prone. Since manipulating strings is it's not an easy task to do. Whenever you have a language trying to generate another language, right, it's very error prone, right, because it's just not the natural way that you generate. Yes.
When you're doing the document.write method, how does it decide where to write it to?
It always gets appended right at the end, right inside of the body.
This is not a precise thing.
Oh no, not at all. And we would never do this. Okay. Yes, that's why I'm not even demoing it. I'm just pointing out the fact that we can manipulate the DOM, right? Yep. Events, we can also handle events using the onclick attribute of an element, so that we can associate an event on that particular element. There's a family of events like double click and hover and enter and exit. There's a whole bunch of events, each one having its on and then whatever the event is. And we can associate that event on that particular element to invoke a particular function to be able to handle it. So we call the functions, we call them event handlers because they have been bound on a particular element to call that particular function. So in this case, we have a particular button that if we click on it, it calls the say hello, which then alerts saying say hello. So one point here is that typically these scripts, naturally syntactically the correct place to put these scripts are in the head of the document, right? So that they're the first thing that they're interpreted, right? And they run, they execute. Any function call gets called. Any function declaration gets declared, and so on and so forth, even before any of the rest of the document gets parsed. So if this content of the script file is pretty big, right, the rest of the content won't be generated until this JavaScript gets interpreted, right? So that has forced perhaps some of these larger JavaScript files that need to be loaded, libraries that need to be loaded on the page, to load them last, load them at the very bottom of the page as opposed to loading them at the beginning, because they could be very expensive to load, right, and to interpret and to run before we get to showing anything on the page, and especially with pages that that on finicky websites that folks don't have any patience. If it takes half a second, we're out of there. We want to show something real quick as fast as possible to the user, to keep their attention. So oftentimes we put all these scripts loading. We put them at the bottom. The very last thing we do at the end of the body, as opposed to at the top, right? Even though it's syntactically incorrect, it's just as well. It works just as well. Yeah, exactly. So instead of putting it where syntactically it should be inside of the head, right? We often find ourselves putting the scripts at the very bottom of the body, right? To improve the performance of loading the page. A couple other things. Up to this point, the examples that we've been looking at were about appending at the very bottom of the content, right? So just whatever was rendered, we could just keep adding to it. Or what you could do is also manipulate some content that's already there, right? That already has a particular heading, a particular table, a particular UL, so it's already been rendered, and you want to come back later, right, and retrieve those elements and then manipulate them. So you can do that, certainly. We can retrieve something that has already been rendered. For instance, here span with the ID of result has already been rendered, but it's empty. There's nothing in there. So we can come back later and retrieve an element that is already in the DOM, right, as opposed to adding a new element. We can come back and retrieve existing elements, and then just change their content. We can say change their inner HTML. Well, whatever's in there, replace it with whatever I'm going to give you here. So we're replacing it with 5 here. We can also interact with fields, form fields. We can dynamically change their value. We can get their current value if somebody has typed something on an input field. We can retrieve their value first by retrieving the element by its ID. Here we're retrieving the input field ID A. And then we're retrieving the value. Whatever, if anything, that the user had typed in there, we can retrieve it as a string. We would then have to obviously make sure that we cast it or convert it into the right data type. If it's an integer or date or whatever, we would be responsible for making that manipulation. But typically, it's just a string, right? Whatever's in that input field. Here's a little tiny little calculator where we have 2 input fields that we type the values of A and B, and then when we click on a button, it calls a function that adds those 2 values and it displays them in the span C. Okay. So add A plus B. Here's the function. It retrieves the 2 values A and B, parses them as an integer, right, and then calculates inner HTML as A plus B. Notice that if we had not parsed them as integer, right, it would have concatenated in the values. So 2 plus 2 would be 22, right, as opposed to 4. Right, so just be careful to cast and convert everything in the right data type. Other things here. So up to this point, we've been working with just literal strings, dates, integers, floats, and whatnot. There's also compound data types where you can combine integers with strings, with dates, all together inside of objects. Objects that can be an amalgamation of multiple data types, and arbitrarily complex objects that can contain other objects, that can contain arrays of objects of whatever. Right? It could be fairly complex, and this notation uses the curly brackets to group together attributes. Right? In this case, it's a house. It has rooms, bath, and square feet. But one of the attributes could be address. And that address could be another object inside of the house, right? Each one could be street, zip, and city, and town, and state, and whatnot. And you can contain arrays and objects, and as arbitrarily as you want. The notation is called JSON. JSON is a JavaScript object notation, and JSON pretty much has displaced the XML as a data transfer format of choice, since XML was pretty big at the turn of the century as a means of sharing data across multi-processes that were communicating across the network. With the advent of the web and the explosion of web applications and moving a lot of the applications that were desktop applications now moving towards web versions of those same applications, they have become so sophisticated, and the communications with their databases and whatnot, that JSON is now pretty much pretty standard as a means of communicating amongst a network. So to represent data and objects that move across a wire. So we're going to be using JSON quite a bit to represent data back and forth to the server. Once you have an object, you can then use the dot notation to navigate the data structure, starting at the name of the object, then dot attribute, dot attribute, dot attribute, dot attribute. So you can navigate all the way through to retrieve each one of these elements. So here's an example of having this HTML where you have LIs that are empty, but they have their IDs, ID of rooms, baths, square feet. So we're going to dynamically use the object we generated earlier, right, to dynamically populate it, right, by, here's our object. We're going to retrieve each one of these elements by their IDs, rooms, baths, and square feet, right? And then we can manipulate their inner HTML and populate them with the values of the house. House.rooms, house.baths, house.square feet. Script, so, disallow? So JavaScript is very forgiving, right, on certain aspects of allowing you to do certain things that are not good practice. For instance, being able to compare certain values where some of those values could be casted in such a way that they would be comparable. For instance, comparing a value of an integer 1 with a character 1. Right? If you compare them normally, they would be compared as being true. They're equal, even though they're different data types. Right? So and this is true for a lot of the rest of the language. Oftentimes, we want to disallow some of these loose, fast and loose behaviors of the language, and we can stop that, but we can enforce a much more stricter checking of variables, of using for loops and if statements and certain other behaviors, by including the following string in anywhere in our code. Use strict, in quotations, with semicolon. Right? The browser will parse this string and says, you want me to verify? You want me to be strict about checking certain things about validation of certain aspects of the language. Iffy, as I mentioned earlier, it's a pattern that it's widely used for being able to handle different namespaces, where if you have multiple JavaScript files that you're loading, they're all being declared. All the variables and functions would be declared on the same namespace. So the only way to declare a separate namespace is inside of a function. Any variables and functions declared inside of a function are only accessible within that function. Right? They don't litter the rest of the namespace. Right? They're only local variables within that function. So JavaScript, we can implement the same, that we can take advantage of that feature to be able to, by wrapping our entire application inside of iffy statements, right? So for instance, you have an anonymous function that has no name. There's no need for it because nobody's actually going to call it. Nobody's going to actually invoke this function. Instead, we have these parentheses at the end, right? It's the invocation operator that basically looks at whatever's on the left-hand side, right? In this case, a function instead of a parentheses, and expects that to be a function. Indeed, it is, and invokes it, runs it. Okay, without needing to call anything. Right? The whole point is that you don't want to use any variables, right? So that you don't litter or compete with any other variables or any other functions that some other library might have declared. Okay, whether it's jQuery or Angular or any other library, they all declare their own things, right, on the global namespace. We don't want to be competing with any of those libraries, right? Now they don't follow the same rules because they themselves declare things on the global space, right? They declare jQuery, they declare Angular. These are all variables that they declare on the global namespace. But when you become as famous or as successful as Angular or as jQuery, go ahead and declare your own global variable all you want. But not until you become as famous as them. Yes?
You refresh the page and this script loads and it runs this function one time?
Yep, it runs one time. And so inside, you would be declaring any variables that you need, any functions that you need, right? And you would have all your logic in there, and it would not be littering the rest of the namespace outside. Yeah. It's basically a module. it's what classes do. It's what imports and exports do in other languages. So here's a little example on implementing a simple to-do list using JavaScript. It's so it's in the to-do.html. We have a single input field at the top, right, with the ID title. Then down below we have a text area with the ID description. Right, so we want to have a little to-do with the title and description of what we're going to do. And down below we have a button also with the ID of add button with a title with the label add. And then we have an empty unordered list with the ID to-dos, which is empty. It has no current, we don't have anything to do. And then we just load todo.js. That loads at the bottom and implements this function here, implements this script over here. The first couple of things that it does is that it grabs a hold of the title field, right, and it stores it in a local variable. Also grabs the description field and stores it in a local variable. It also grabs the add button, and so basically it's binding all those elements that are on the HTML. Is bind them in local variables so that for further manipulation, right? So for instance, we want to read the title, we want to read the text area, whatever you type, we want to read it, right? So we want to have a hold of references to that. We then bind an event handler on the add button. We say the add button, if there's a click on the add button, call that this function, right? And the function is the event handler. So whenever we click on that add button, this function will be called, add button handler, okay? So in that function, what we're going to do is that we're going to use those variables we bound earlier, the title and the description. We're going to read whatever if you click on add button, what we're going to do is we're going to read the title, we're going to read the text area, right? And what we're going to do is that we're going to dynamically generate an LI, a brand new LI, and we're going to add it to the empty UL. Right? So every time you click on the add button, that's what we're going to do. We're going to grab the title, the description, we're going to create a string representing the LI with the title and the description, and then we're going to go back and append it to the UL. So what we're going to do is that we're going to there's a description, the title. We're gonna generate an ID, a unique identifier. We're going to create a unique identifier so that each LI that we generate, we're going to have a unique identifier, right? So that if we wanted to remove that to-do list, we will know which one to remove, right? So that they're uniquely identified. So the way we're going to generate a unique identifier is using getTime, right? So that they'll just get the last millisecond since, I don't know, 1970 or whatever. And we're going to use that as the ID of the LI, and we're going to add the title as part of the LI, and we're going to also add an attribute on the LI, on onclick, that will invoke a delete note that will pass the ID to that delete note when we click on the X span, right, at the end of the LI. And then finally we use another function here, part of the JavaScript DOM API, that allows us to insert not in the inner HTML but insert as an adjacent. So as opposed to replacing all the entire content, leave what's already there, as opposed to replacing it completely. Just append to as an adjacent element. Okay. So if we already have some LIs in there, I don't just want to replace the entire thing. I only want to append to whatever's already there. Okay. So the delete note, basically what it does is that I know the ID and it's being passed to us. We just retrieve the element by ID, and then we can just remove it. .remove. It's gone. Right. So there we have it. So we have a simple to-do list just with JavaScript. All right.